Weight reduction is one of the most effective methods to reduce carbon dioxide emissions. Manufacturers and suppliers in the automotive industry are putting great effort into producing powertrains and their components in lightweight design. Currently, however, camshaft modules, which are a key component of powertrains, are still being made from aluminum.
This is the camshaft module, which is a part of the cylinder head, mounted on the internal combustion engine. It's situated in the upper part of the engine bay, and therefore it is particularly important to reduce its weight, as it also contributes to the lowering of the overall center of gravity.
In collaboration with partners, our researchers now have succeeded in manufacturing a camshaft module made of fiber-reinforced thermoset polymers. Its lightweight design helps to lower the engine weight and reduces the assembly costs. In choosing the polymer material, the project partners opted for high-strength, fiber-reinforced thermoset polymers, as they are well able to withstand high temperatures and mechanical and chemical stresses. Our researchers then designed the component geometries to suit the material and the process, meeting all requirements.
Even if the overall stiffness of the applied material is only a quarter of that of aluminum, our designers were able to design the part in such a way that the deformations of the part can be reduced to an acceptable level.
The design and the manufacturing process were analyzed using numerical simulation methods. For instance, the injection molding process was virtually investigated with a mold filling simulation performed by the material supplier to determine the process parameters and to ensure that there is no air trapped in the final prototypes. The prototypes were tested for 600 hours on an externally driven engine test stand. The lightweight module showed flawless functionality. With the aid of the planned fuel injection tests, the project partners will demonstrate the functionality and the NVH characteristics taking the gas pressure forces of the combustion process. Besides the weight reduction of approximately 0.6 kilograms, the lightweight module has further advantages. Fiber-reinforced thermoset polymers allow a near-net shape manufacturing, thus requiring comparatively little reworking, which again leads to reduced production costs. Also, at up to 500,000 units, the service life of thermoset polymer injection molds is significantly higher than that of aluminum high-pressure die-cast molds. The camshaft module features a monolithic design with integrated bearings. In other words, it is manufactured in one piece. Car manufacturers receive a pre-assembled module from their supplier and can mount it on the engine with just a few simple mounting operations, thus reducing assembly time. And there is another advantage. Automotive manufacturers are eager to minimize noise emissions. Polymers have good damping characteristics, enabling the acoustic performance of the camshaft module to be optimized. In summary, the prototype of the camshaft module demonstrates the great innovation potential of plastic materials.